This is the Raspberry Pi computer. Yes, it is a complete and operable computer. It has 512 megabytes of RAM, a 300 MHz processor that can be overclocked, a GPU. It has the following ports: 2 USB ports, a LAN port, an RCA video line, a line-in audio port, an SD slot, and a micro USB port used for power. I am connecting to it an 8 GB SD card, which I loaded with the Raspberry Pi operating system, which is a version of Unix. This is my keyboard receptor. This is my mouse receptor. This is an HDMI line connecting it to my TV. This Cat5e line with an RJ45 connector is connected directly to my Netgear router provided by Consolidated Communications, formerly known as Sure West. Lastly, I am connecting a micro USB cable. You can use any phone charger that supplies at least 5 volts and 700 milliamps, but I am just connecting the cord straight to my laptop USB port for power. For my project demonstration, I chose to set up this computer to act as a web server. I would have liked to have tried using its graphics capabilities, but I lacked the time and resources. Since I am connecting this device to the internet, I am first going to log in and change the password from the default. Simply type passwd and follow the prompts. I have made a new account called User1. Edit the permissions of the new account so that it has access to the same group as Pi. Use the command sudo nano /etc/group to edit this file with the nano editor. Put a comma and user1 after all lines that have Pi on them. Exit and log in under your new account. You want to set your account's default shell to bash, otherwise certain functions will not work. So do that by entering chsh, that's the change shell command, with -s/bin/bash. Enter the command sudo raspi-config and go to Advanced Options. We will cut the amount of RAM being used by the GPU in half, since operating a web server isn't graphically intensive. Then reboot again. To configure the Raspberry Pi for networking, we need to set a static IP address. Type ifconfig to find out your DHCP address. Use the route command to find out the address the router is using. Finally, you must access your router and find your address range that is issued by the router. With most routers, the default account information and IP address are listed on the router itself. Type the address into a URL bar of a browser and log in. If you have a router from Consolidated Communications, it involves calling them up, getting put on hold while somebody vainly tries to figure out what you want, getting hung up on twice, and finally getting someone to remotely log into your own computer and enter the username and password for you. It is a stupid thing they do to make their equipment more secure, and they didn't even show me the correct information before disconnecting. I made a guess for my range and it worked out. Now, to change to a static IP address, change the directories to /etc/network and enter sudo nano interfaces. Replace the line iface eth0 inet dhcp with iface eth0 enet static. And directly below that line, enter address followed by an address within your DHCP range. Below that, enter net mask and the mask value shown by the route command. And below that, enter your default gateway. Do a sudo reboot so the changes can take effect and type ifconfig to make sure that they have. Next, we are going to allow for SSH remote login. Again, type sudo raspi config and go into Advanced Options, SSH, and Enable. That's it. Assuming you don't have consolidated communications, you should have no problems configuring your router to allow port 80 HTTP and port 22 SSH to be permitted through your Raspberry Pi IP. Install Apache Web Server by typing sudo apt-get update and then sudo apt-get install Apache 2. Install MySQL with the command sudo apt-get install mysql-server. Add a password if desired. Lastly, install PHP with the commands sudo apt-get, install PHP 5, and sudo apt-get, install PHP 5 MySQL. If it worked, you should see this web page when you type your static IP address into a URL bar.